Welcome to Perfection's Clutch Installation Lab. Today we've got a 2004 Dodge Ram 3500 5.9 liter Cummins with a 6-speed NV5600 transmission. About 240,000 plus miles on the truck. Now this is a work truck. Flatbed, 4-wheel drive, dually. It's got a lot of hard miles on it and it makes a lot of money for its owner, and it's time for a clutch. It came to us today on a flatbed wrecker. The clutch is gone. There's nothing left of it. And while I was working the clutch pedal today, pushing it down, I actually managed to snap the pin that's in the clutch pedal that pushes on the master cylinder push rod. So we've got some work to do. So we're going to take a look at how we service this NV5600 Dodge Ram Cummins. Now there's a dust boot that's screwed to the floor. Take those screws out. Then underneath that, there's 4 bolts that hold the shift tower on. So we're going to undo the last bolt. Take the shift tower out and catch it with a rag because it's going to have some oil on it probably. Then I'll take a towel and cover the hole in the transmission. I'll do that carefully. I want to keep any debris, dirt, screws, sockets out of there. I want to catch them right there. You don't want to have something going down inside that transmission. Now we did take the transfer case off to get the transmission out. Just made the package a little smaller for us to handle. The cross member had to come out, of course the rear drive shaft, the front drive shaft, the clutch hydraulics, a couple of connections for the reverse gear position. So now the transmission is out. And when it came out, we had some ball bearings kind of fall to the floor. These came out of the clutch release bearing. Clutch release bearing is gone. This is the race that's supposed to be rotating, and it had stopped rotating and had burned a hole through the diaphragm spring. Now this is the race, the front face of the bearing that's supposed to turn. It touches the diaphragm spring tips. It's always turning when the engine is running. But this bearing stopped turning some while back. We don't know what's caused it yet. And when it stopped turning, it just burned a hole through the diaphragm spring fingertips. We're going to take a close look at the bearing and see if there's anything on the bearing that we can read to tell us a little bit about why it failed, or was there anything in the installation of the bearing that might have contributed to this. Also, whenever you're driving these vehicles, you need to take your foot off the clutch pedal. When you put your foot on the clutch pedal, you're only adding to the load applied to the bearing. There's a spring inside the slave cylinder. It applies a preload through the clutch release fork. That's normal, but your foot can overcome that preload, add more force to it, and cause the bearing to run hotter and fail sooner. Make sure you take your foot off the clutch pedal when you're driving. But let's take a good close look at the clutch release bearing. Again, the part of the bearing that's supposed to rotate, all burned up. Part of the bearing. This, I think, is part of the rear seal. We've got some balls down there. We're going to take the fork off. There's a clip on the passenger side that holds it on. Then the push rod. And there is an orientation of this fork. You need to observe that. Now one of the clips that holds it on is pretty well mauled. We do have a new fork on order. And the inspection points on the fork right here where it touches on the back of the bearing. Got a nice flat spot there now. There used to be a nice crown there. So that's a good reason to replace this when you have a flat spot instead of a crown. And this is 240,000 miles. So we're going to go ahead and replace that. And the orientation has to do with the position of the part number. But here's the thing I really want to look at on the clutch release bearing. And to me it looks like it happened. There's a groove right here in the middle of the bearing. That groove is a grease groove or an annular groove. It does not at all show any grease. The only thing that's in there is dust. I would expect to see greasy residue inside there. And the front of the transmission here is dry, and actually this is the most wear I've ever felt on an NV5600 transmission. Also the highest mileage, but the most wear. So we got a little work to do to clean that up, and I believe this bearing was installed incorrectly without being greased at the time of installation. Now I've got one bolt holding it in, it's loose, but I've got it on 2 pins that I made, and I'll show you those in just a minute. Now, this clutch, in the condition that it's in, these sharp diaphragm spring tips now, you can be very careful when you handle these. These are very sharp, and you definitely don't want to cut your hand up with one of these. Now the clutch is hanging on 2 pins. This flywheel does not have dowel pins, so I just made some bolt pins. Pull it off, and there it is. "13-inch organic disc." They are pretty much worn all the way down to the facings. Pilot bearing is still intact. That's good news. Flywheel is very deeply worn. Boy, we're going to be able to measure that one. You can really feel it. It looks like somebody might have just scuffed it up previously. Flywheels, when they're made, have machine marks from a lathe going all the way around. When they get resurfaced, they'll have a mark, usually in an arc like this. This one just looks swirly, like they took a little buffer and cleaned it off. We'll get a close look at that too. But this is deeply, deeply worn. We are replacing that flywheel. Time to take the flywheel off. I'm going to take the 12 o'clock bolt out first and replace that with a pin. Again, a bolt, same size, pitch, no head. And that's just going to hold that flywheel, because this 50-pound flywheel does not have anything to hold it on. NASCAR's got nothing to worry about with me. Those tire changers are sleeping good tonight. Now, if that pin wasn't there and I take the last bolt out, this flywheel's coming down. Pins in. And there it is, safely off. Now I cleaned the transmission case up a little bit in here, in particular the areas of the guide tube, the splines. I even used a piece of Scotch-Brite and a screwdriver, got down inside each tooth, get those really cleaned up, and the section of the input shaft that goes in the pilot bearing. Very, very important that all this is clean. Now with clean hands, I'm going to take the clutch disc and slide it on the input shaft and make sure it fits. It has to slide. There's no force required to install this disc on the input shaft. If something's tight, something's wrong. Okay. We put a spline lubricant pack in each kit. You can use number 2 wheel bearing grease, high temperature wheel bearing grease. I'm just going to distribute the grease. And the trick here is to try and keep your hands clean. Sometimes that's not always so easy. Then I'm going to fold the pack and draw it down between each tooth with the grease on it. Okay, we've got the grease in the teeth of the splines. Now, clean hands again. Take the disc and slide it on. Slide it off, index it. You just want to distribute that grease. Get on all the tooth flanks. The grease helps prevent rust from forming. This is steel. It's kind of inevitable that it's going to rust. But this rust right here, if you get rust in the splines, or if you install a transmission with a rusty spline, the rust inhibits the disc's ability to slide on the input shaft. You get a hard release, grinding into first or reverse, notchy shifting. So please, take a minute, clean those input shafts, and just a little bit of high temperature wheel bearing grease. Not anti-seize. Anti-seize goes from here out to here. It flings out. Gets on the friction material. Big no-no. You've put an anti-seize compound of some type on friction material. Now I really feel this one small thing was a major contributor to that last clutch's early failure. The grease groove in here was not lubricated. Whether the bearing comes with or without, If it's steel, aluminum, cast iron, and it's rubbing on metal, you need to grease it. There's a groove in there. Now I purposely cleaned the grease out of this one so we can just demonstrate what we got to do. I want to fill that entire groove with grease. This is just high temperature wheel bearing grease. No anti-seize. Now I'm going to take a little bit of grease, just a little bit, put some back there, and I'm going to clean up all the excess when this is all done. Okay, that's looking a little better. Now another feature about the bearing, self-aligning. Here at Snap, the face of the bearing is held on with a friction system. As you push on the clutch pedal, the clutch cover diaphragm springs will grab a hold of the clutch release bearing and move it where it wants it to be. So if you see a gap at one side and a smaller gap at the other, don't worry about it. It's a design feature. You can't preset it. Just install it and push on the clutch pedal. It'll take care of itself. Now here's our new clutch release fork. I marked it in white paint. This is the two areas on the fork that are radius, that have a crown to them. That's what pushes against the flat spots on the back of the bearing. So the correct installation is like this. And the reference is with the part number down here in the lower left. But there's something unique about the Dodge fork in this application, and the NV5500 and the G56. You can flip it around. When you flip it around, you've got a flat spot pushing against a flat spot. That's incorrect. You want a curve to a flat. So make sure when you install and service these that the part number is in the lower left-hand quadrant. Now to install the fork and bearing, we just put a little bit of grease in that pocket, just a little bit, and put the clip on, the retainer. Make sure that the clip goes all the way across the fork. Then the pivot ball will go through there. Okay, so there's our orientation, part number lower left. Another area you can put a little bit of grease is right there where the fork and the bearing touch each other. Put the clips in. I actually had to put the fork down on a bench in order to walk the clips underneath it. So let's go ahead and complete the installation. Carefully slide the bearing on. Center up the clip. And push it on. Now the slave cylinder push rod will come through from over here and push the bearing forward. And now just clean up this excess grease from the bearing install. We got a pretty good looking transmission now. Now this is something I always check every installation, no matter what. The dowel sleeves. They control the alignment of the input shaft to the crankshaft and to the pilot bearing. The pilot bearing does not center the input shaft, it supports it. The previous installation, I think they used the bolts to pull the transmission in, because I found a burr like this, a big sliver, from the dowel sleeve pushing in hard against the case and being pulled in by the bolts on both sides. Always, please, be patient and careful as you install a transmission, because as you damage these holes, this is what controls that alignment. And if the alignment is not in control, we have wear on the input shaft, we have wear in the clutch disc torsion damper. Always check these, please. Now to install the flywheel, I'm going to start by inserting that pin bolt that I made up. It's the same size and pitch. Cut the head off, a little slot in it. Again, 12 o'clock position. Because this does not have very much of a shoulder to hold the flywheel. And I don't want to have a 50-pound flywheel come down on my feet. So up on the pin. Get it seated on the crank. And start some bolts. I'm going to draw this down in about 3 steps. First with a 3/8 ratchet, then I'm going to switch to 1/2 inch torque wrench, set to about half the final value, which is about 100 pound-feet of torque. Okay, the bolts are seated. First torque, about 50. Now I'm going to go for 100. I need to keep the flywheel from moving. So I just use a piece of this little channel strut. I've got 1 bolt going to the flywheel for the clutch cover, and just putting 1 bolt, seating it in nice and deep on the adapter there. If you had a barring tool for a Cummins, you could insert that up here where it goes. This is used to turn the engine over for servicing. You could lock the engine in place with a barring tool. 100. And a final check. Now I already installed the pilot bearing while it was on the bench. I used a bolt and actually pulled it in. I used a nut on the back side. You could tap it in with a hammer, use a socket for example, or a driver. If you had a press that had a deep enough throat, you could press it in. Just be careful, don't give it a direct blow if you're going to use a hammer. Put some kind of buffer in there. But it's already installed and I want to leave it alone as much as I can. Now the alignment tool is going to go in a minute when I pick up the clutch disc, but I'm going to leave that grease where it is. Now to prepare the flywheel for the clutch, some brake clean on a clean rag, or you could use rubbing alcohol. Don't use any type of fuel. You want to make something that takes that cast iron dirt off, and the preservative, oil, whatever it is. There we go. That's looking good. Now there's nothing to clean on the clutch disc. We leave that alone. But I am going to clean the friction surface of the pressure plate. Just the surface that it touches the clutch disc. To install the clutch, I'm going to put my pins back in. These are just bolts without the heads, little slot cut in them. Notice the flywheel side orientation of the disc. I'm just going to start a bolt. Now I want to take the alignment tool, pick up the splines, going to lift the disc up a little bit, there we go, catch the pilot, you want to take an extra minute here and make sure that you have everything lined up just the way you want. Go through the splines, pick up the pilot. No sense fighting it later. That feels good. I'm going to go ahead and continue with the bolts. Alignment feels good. Now I'll start tightening these in a staggered pattern. Final torque, 22. 1, 2, 3, 4, 5, 6, 7, 8. We're all torqued, ready to install the transmission. All right, now Travis is here, and in just a minute he's going to push on the clutch pedal. Now when he brought the truck in, there was a real problem. This clutch was destroyed. So what he felt before, I hope is going to be nothing like what he's going to feel now. Travis, why don't you go ahead and push that clutch pedal and see what it feels like. Hold the brake there.
It's consistent. Smooth and consistent.
Smooth and consistent. Your clutch was destroyed. There was like nothing left of it. It was a real problem. Now you've got a new clutch, new fork, the throwout bearing's been serviced correctly, did a couple other things to help tune it up a little bit. But this is what this clutch pedal could feel like, and it's probably what it felt like when the truck was first built.
It's impressive.
Feel like it'll be a little easier to drive too, won't it?
I think so.
All right.
Just a little.
All right. Let's take a look at the parts, okay?
All right, let's do that.
Well, the job is over. The clutch is installed. Shifts real good. Takes all the power that Cummins has. Let's take a closer look at these parts and read these parts. See what happened to them. We'll start by looking at the flywheel, the foundation of the clutch. I can use a feeler gauge and slide about a 16,000ths of an inch blade underneath it. But it's actually worn down more than that, about 21,000ths of an inch using a precision depth mic. When I talked to the owner of the truck and said, what happened at the last clutch change? Why didn't you guys resurface the flywheel? It was his harvest season. He had to get the truck back online. Paychecks were waiting, so didn't have time to resurface, and this is what he's got. The clutch disc, intact. Friction material's worn, but there's still some disc left. It's still there. But now we get to the pressure plate assembly. This is where things start to get ugly. As you saw when we removed the transmission, the clutch release bearing just fell apart. There was nothing left. The flywheel side of the pressure plate, we're looking pretty good there. The clutch disc side, it's a little bit hot, but I've seen a whole lot worse. So what caused this bearing failure? Was it a bad bearing? Well, there's the bearing race that rotates up there, and as you can see, it just burned a hole clean through the diaphragm spring fingertips when it stopped rotating. But I think we have to look a little further than that. We have to go to the clutch release bearing carrier or collar right here. And if you look down inside, right here, this groove, this grease groove is not greased. Now you saw I very carefully greased it, made sure it was greased, made sure it felt real good. The clutch fork moves the bearing in an arc. The front bearing retainer takes that arc and straightens it out. So there's a little bit of a war going on there, a little friction between the two. Arc to straight line. This has to be lubricated. You can also put some lubrication back here on the ears of the collar. But without that being lubricated, the bearing was hard to push. This would have been a hard pedal. It probably would have stuck on the front bearing retainer at some point in its life. But it also would apply too much preload to the clutch release bearing. That excessive preload burned the bearing up from the inside out, and then finally the whole thing died. So in my opinion, that little bit of grease right there in the grease groove is really what caused the total premature failure of this clutch. Now it also did cause some wear on the fork. Remember I showed you the crown right here, the radius spot of the fork where the bearing rides? We had a big flat spot right there. So there's several small details in the installation that significantly shorten the service life of this system. Well, Travis had to come and pick up his truck. He had some work he had to do. So that's my Dodge Ram with the Cummins with the 6-speed transmission in the background. If you have any questions about a diesel pickup truck clutch, a flywheel, or a hydraulic release system, please call Perfection at 800-258-8312. Press 4, and your call will be routed to Tony, Steve, Bobby, or myself. We'll be glad to take your call and help you out.